So I'm an eye guy. So everyone in this room will suffer from one of 6 possible conditions in which I would advise you to seek out an ophthalmologist. That was just to drum up a bit of business. The eye is a structure in which we're used to using cells as a treatment, especially at the front of the eye. So corneal grafts, limbal stem cell transplants have been used for decades now to restore diseases such as aniridia, where you see the lens going white, and also in conditions where acid or alkali sadly has caused the same problem. But the eye is about, from the front to the back, about an inch, and there's a number, believe it or not, of specialities in that inch, and I'm a back of the eye guy. So I'm more interested in the structure which is involved in vision itself. And what I just want to present today is 2 areas in which cell therapies from stem cells are now being utilised. Specifically one that I'm majorly involved in, which is the use of cell therapies for age-related macular degeneration, which is a clinical condition which affects over the age of 65, about 25% of the population. So it's a huge problem. But we've approached it in a very different way, in that we've combined both cells and an artificial patch to deliver what needs to be a carpet of cells, a single layer of cells. But in age-related macular degeneration, you lose your central vision, your what's called high visual acuity, your ability to drive, your ability to read, your ability to recognize friends and family. So this is a horrible condition which clearly is age-related and over 65. So I'm going to present in the next slide some of our clinical data in which we've already treated patients. But a second group of patients which suffer from the rarer orphan indications is also an area in which cells are being used. And here in Harvard, Mike Young has just started a trial with a British company, Reneuron. And there are 2 possibilities. One is to use the cells themselves to stop those cells from dying, or to in some way try and transplant those light-sensitive cells. So they are the 2 major areas which are already resulting in cell therapies already, which have gone to clinic. And there's a number of groups, both in Japan, France, Israel, UK, US, who are now either in clinic or have been in clinic. So what did we do then? So we did, this time last year, 2 patients. And this is a joint venture partnership with Pfizer. And basically, we created a 3x6 millimeter patch, which had this carpet of cells, those support cells at the back of the eye, placed onto an artificial membrane. The reason for the membrane was twofold. One is to surgically implant the cells. It gives you a better ability to do that. The second is, it is a carpet of cells, and it has to be pointing in the right direction. So we didn't want to just inject cells. Some groups have, but we envisaged that you would need to use this type of membrane. So this is the patch in our first patient. Sometime after the actual initial operation, it went into patients who had very bad bleeds, so the form known as wet AMD, in which the patients could not be treated with Lucentis. So the patch is there, it's fully covered, it's been in these patients now for 12 months. The beauty of the eye is you can use very simple imaging techniques to really indicate whether those cells are there. And in this final component, what we have is our patch of RPE sitting underneath a 60-year-old retina with a fresh, new RPE supporting that retina. So we hope to publish those 2 patients, or send them for publication, the clinical outcome, before the end of the year. So thank you very much.